We are lucky to have with us the electronics technician for the College of Engineering and Natural Sciences at the University of Tulsa. His name is Justin, and Justin's going to explain in this video how to use the desktop power supply for the electrolysis we're going to be doing. So, Justin?
Well, greetings and salutations to you all. Here we have the power supplies we've recently acquired for the inorganic lab. These are fairly standard. You'd find them in just about any electronics shop. These are something very similar. What this supply does, basically it pumps electrons from the positive terminal here to the negative terminal there. It will continue to pump them, and it will pump them as fast as it can until either so many electrons have built up at the negative terminal that it hits its voltage limit, or it's pumping them so fast that it hits its current limit. So you can set both of these limits with these knobs, voltage limit, current limit, and whichever one is more restrictive will be the controlling limit. So we've got it plugged in here. We'll turn it on with an open circuit at the terminals. Turn both of these knobs all the way down. You can see we've now got a voltage reading and a current reading, and they're both very close to zero. The light here next to the current knob is on, telling us that it's the current control that's presently limiting the rate of pumping. So I'll turn that up, and we very quickly go into voltage limiting instead. I'll turn voltage up, and you can see that voltage increases with no real change in current. That's because we can pump electrons over here. There's no real path for them to make their way back here, so it takes extremely little current to build that voltage up. And 18 volts is just about the limit that this supply can output. Now I'll turn it off. We'll connect our alligator clip leads here. And I will short the output. So now we've gone from an open circuit to a closed circuit. Again, I'll turn these knobs down, turn it on. Now we're slightly limited by voltage. I'll turn that up. And what we're going to see now is that as electrons are pumped this way, they can make their way immediately back to the positive terminal. So we can pass a very large current without developing much voltage. In this case, we've hit about 2 amps, again the limit of the supply. And you can see voltage remains very low, and it's the current knob that's controlling everything. I'll turn that off. I'll turn both of these controls back all the way down, and connect to the tube over here. This is more of a physical mechanical challenge than anything else. We'll connect to the cathode here. Hope that it doesn't pull too far out. Connect to the anode there. I'll just make a quick visual check that the cathode hasn't been pulled out of the solution by the weight of the negative lead here. Nope, it looks pretty good. Alright, so now I'll confirm that these knobs are all the way down. Turn it on. Start increasing the current. And we very quickly go into voltage limiting. So I'll kick the voltage limit up quite a bit until we go back to current limiting. Our target current for the lab today is 1.2 amps.
Correct.
This may or may not be the case when those of you viewing this take the lab. But I will turn the current up here until we hit 1.2 amps, keeping an eye on the LED, make sure that we don't go into voltage limiting. Alright, you can see we've developed just about 6 volts. That means that we have a resistance of about 1/2 ohm in the whole electrochemical system here. And now I'm going to take the voltage limit here and turn it down until we go into voltage limiting, so I know it's right at the voltage where this reaction needs to run. And now I'll turn it up just a bit more so that we go back to current limiting. So that just makes sure that if anything goes wrong here, if something shorts out inside or outside the tube, the supply doesn't jump up to a much higher voltage. We know that it'll now only go up to maybe 6.5-ish in the worst case. And that's about it. You can run your reaction here. When you're finished, just turn the supply off, disconnect the leads, and that should be about it.
Thank you very much, Justin. Really appreciate you taking the time to help out.
And next time, let me know and I'll get a haircut first.
Oh, no, your hair is not long enough, actually. I'm just kidding.
So
Personal
simple to
bias. That's right. All right, thanks again.
No problem.
Bye.